Dear students, in this session, let us discuss about the Pitot Tube. A Pitot Tube is widely used for research purpose in fluid mechanics, as well as it is used in fluid mechanics for measuring the velocity in a fluid flow. Before proceeding to Pitot Tube, we should know some fundamental difference between the various types of pressures. Already we have discussed about the atmospheric pressure, gauge pressure, and absolute pressure when we are discussing about the manometers. Today, let us explore some other uh, different forms of pressure which will be useful to understand the concept of Pitot tube more clearly. The pressures involved are, the first one is static pressure. So when the pressure of a fluid when is at rest is called a static pressure. Then we'll go for dynamic pressure. The third one is something but called as stagnation pressure. Otherwise this is also called as total pressure. So we want to discuss about these pressures today. The pressures are static pressure, dynamic pressure, and stagnation pressure or total pressure. So when I'm telling us total pressure, I hope you got it. The total pressure will be equal to 1 plus 2. What is 1 plus 2? Is the summation of the static pressure and the dynamic pressure. So the stagnation pressure or the total pressure is the summation of the static pressure and the dynamic pressure. So first of all, we should be very clear with these three terminologies so that we can appreciate the usage of Pitot tube in measuring the velocity of the flow. So the main purpose of the Pitot tube is to find the velocity of fluid flow. This also is going to apply the basic principle of Bernoulli's to find the velocity. Now let us have like this. Now there's a flow which is happening through a pipe. Let us consider the fluid to be water. So it will be easy for us to consider or to realize it. Now my question is whether this fluid is moving is fine. It either can be moving or static. It's not a problem. But now let us consider a case when the fluid is moving. And now, what about the layer of the fluid which is touching on the wall? Whether it's moving means it is not moving. It is considered to be as no slip boundary condition. That means we assume that the final layer of the liquid which is going to in contact with the solid doesn't move. Now, this fluid particle will exert certain pressure on the wall. These particles are the fluids which are in contact with the solid surface will exert certain pressure. This pressure will be equal to what? Force by area. Definitely this fluid particles exert some force on a particular area and this pressure is called as the static pressure. So we can see if I'm going to make a opening from here, now the fluid will be trying to move. Now what is the pressure which can measure at this location is called as PS. The PS stands for the static pressure. So now you got it, whether when a fluid is moving or it at rest is not a problem. But definitely this fluid particle will exert certain force on the surface of the wall. This pressure is called as either static pressure or sometimes they used to refer as what? Wall static pressure. And since the fluid is flowing, there's another pressure associated with the fluid. It is called dynamic pressure. Because of that pressure only the fluid is able to move. That pressure is called as what? Dynamic pressure. So now we come to know what is meant by static pressure, what is meant by dynamic pressure. If I'm going to add both these things, then I'll get the total pressure or the stagnation pressure. So I hope you are very clear now with the terms static pressure, dynamic pressure, and the total pressure. I'll repeat once again, when a fluid is flowing or when a fluid is at rest, in both the cases, the fluid will exert certain force on the surface of the solid surface. This force per unit area is called as static pressure or wall static pressure. This is the first one. The second condition is that since the fluid is moving, the dynamic pressure will come only into picture only when the fluid is moving. When it's static, there is no dynamic pressure. Since the fluid is moving, it should have certain pressure. That pressure is called what? Dynamic pressure given by, if you want, you can, this is PD. And generally, the total pressure will be the summation of the static pressure and the dynamic pressure. The total pressure or the stagnation pressure will be equal to the summation of the static pressure and the dynamic pressure. Okay. With this concept in mind, let us try to now go with the Pitot tube. How the Pitot tube is working, or how the Pitot tube is able to measure the velocity of the fluid in a flow. Okay, fine. So a Pitot tube is an arrangement, a simple arrangement which has have a L-shaped bend. So you can see the bend is as a 90 degree. Okay. So you can see this is the Pitot tube. If you want, let us draw this one so that the Pitot tube will be exactly at the middle. Most probably we'll try to place it in the middle. Okay. So this is my bottom wall, this is my top wall, and this is the Pitot tube. The Pitot tube is nothing but it can be either a transparent tube or a oblique tube also, but it should be at a 90 degrees. Now, with the fluid particle, now let us try to take some fluid particles which are approaching along this center line. Now let us take this point as 1, which is far away from the location. Now let us take another point 2, and let us have like this. Now what I am going to do means I am going to consider the streamline or the particles which is traveling along the line 1, 2. I am going to consider along the line 1, 2. If you want to please extend the domain. Okay, I hope now it's clear. So the point 1 is here. The point 2 is exactly at the tip of the what? This Pitot tube. Now the condition is that at point 1 the fluid is able to move. At point 2 the fluid is brought to rest. At point 2 the fluid is brought to rest. Instead of that, the fluid tried to convert the kinetic energy into pressure energy. I'll repeat once again. We are considering the flow of fluid particles from left to right. That's fine. Now I am trying to insert a Pitot tube, which is nothing but a right angle tube. And now let us take a streamline or the fluid particle which is going through the center of the tube. Let the velocity or the thing at point 1 is V1. Now the velocity at 2 is brought to rest. It is made to be stopped. So this kinetic energy will be used to increase the convert into pressure energy, which in turns will make the fluid to rise up to here. Got it? Because it's made to stop, this kinetic energy is connected to what? My head. This is my H. This H is coming out of because I am making the flow to be constant. Before the head is constant, before the head has been raised, the actual head is what? This head is what? H. What this H? Can anyone tell what is meant by capital H? You are able to understand small h, I also understand. Because small h is because you are making the flow to bring to rest. Because the kinetic energy is now converted into pressure energy or the potential energy. It's not pressure energy, it's the potential energy. So it will make the fluid to rise up in the tube. So the water level is risen above the height of the tube, height of the pipe, and hence this small h is easily understandable. But what is this small h? What is this capital H? Any guess? Yeah, you are right. This capital H is nothing but the wall static pressure. This capital H is nothing but what? The wall static pressure. What is the pressure which will be exerted by the fluid on the wall? That can be measured with what? Capital H. And the small h will give me the dynamic pressure. Okay. If I'm going to add capital H plus small h, it will become what? The total pressure. That will become what? The total pressure. Okay. If you're not able to answer this h, I will take here. I will take a small region here. And if I'm going to measure the pressure over here, now this pressure will be equal to what? Capital H. Why? This height, this head is nothing but what? My static pressure. So now capital H corresponds to the static pressure, small h corresponds to the dynamic pressure, and the total pressure will be the summation of capital H and the small h. Very good. Now let us try to apply the Bernoulli's equation between the section 1 and 2. Okay, so I am going to apply Bernoulli's equation, principle of Bernoulli's equation, Bernoulli's principle. Now let us try to continue with the Bernoulli's principle between the points 1 and 2. So all of us know that P1 by rho g plus V1 squared by 2g plus Z1. Z1 is nothing but from any datum. So we'll take the datum here. So let it be Z1. What about Z2? Z2 is also in the same height. So let us call this as what? My Z2. So P1 plus rho g plus V1 squared by 2g plus Z1 is equal to what? P2 by rho g plus V2 squared by 2g plus Z2. So now since Z1 and Z2 are same, we can cancel off them. So the final expression will become now P1 by rho g plus V1 squared is the velocity at 1 by 2g equal to what? V2 squared by 2g plus P2 by rho g. It's just interchange, nothing wrong, both are same. A plus B or B plus A. Now, what about V2? V at 1 there is a velocity, but what about V2? Yes, you are right. V2 is brought to 0. V2 at point 2, the fluid is brought to rest, which means my V2 reduces to 0. So this term vanishes. This term vanishes. I hope now I can erase this diagram. So we can see this is a P1 by rho g plus V1 squared by 2g is equal to P2 by rho g. What is P1 by rho g? It is nothing but H. It is nothing but what? H. Because it was only the static. Because there is a velocity component also. So now it will correspond only to the static. Plus V1 squared by 2g. What is P2? At the location 2, it is brought to rest. So it is having a summation of both static pressure and dynamic pressure. So we will have both H as well as this small h. Isn't it? So at 2, we have both small h and capital H. At 1, we have only small capital H. At 1, we have only capital H, which is nothing but the water static pressure, because the dynamic pressure is taken care by this component. But here the dynamic component has been made 0, so it rises to small h. So I hope you can understand this will be equal to what? H plus H. So P2 by rho g will be equal to static pressure head plus what? Your dynamic pressure head. Okay, so H plus H. From this, what is our aim? To find the velocity. So I hope I can cancel off. Otherwise, I'll take this one. V1 squared by 2g equal to H plus H minus H. So this H cancel away. So my small h will be equal to V1 squared by 2g. Or V1 squared will be equal to 2gh. Or if I'm going to take the square root of this one, V1 will be equal to what? Square root of 2gh. Very simple. V1 equal to what? Square root of 2gh. So if I'm going to measure the manometer with the help of the manometer, then I'll get the value of this velocity. This velocity is either actual or theoretical. Yes, you are right. It has been arrived from the formula, theoretical formula, and hence it's called as V theoretical. It's called as what? V theoretical. So I can tell, I can tell you, V theoretical is equal to square root of 2gh. But whether the actual velocity will be less than this one or not? Yes, definitely the actual velocity will be less than this. So how to find the actual velocity? V actual is equal to CV into V theoretical, where CV is the coefficient of the Pitot tube. Where CV is the coefficient of the Pitot tube. Generate value is close to 1, but not 1. It is 0.98. It is what? 0.98. So we can see the value of CV is 0.98 into square root of what? 2gh. So this will give me the actual velocity which is flowing through the pipe. Okay, otherwise generally is not to give the numbers, so we'll go with the formula. So V actual is equal to CV into square root of 2gh. So this is the formula you should recall to find the velocity of the fluid in a pipe. If you know the velocity, then if you're going to multiply with the area, then you can also get the what? The discharge. Even though the primary purpose of the Pitot tube is to find the velocity, from the velocity, if you know the area also, then you'll be able to find the discharge. That is nothing but what? Meter cube per second. Now my question is how to calculate H. H gives me, H is what? Whether it's contributed by the dynamic pressure or the static pressure. The H is caused by the dynamic, because the static is what? Capital H. The dynamic is what? Small h. So how we are going to do this experimentally? That is the main thing which you want to see. We have derived the formula for the V actual is equal to CV into square root of 2GH, where CV is nothing but coefficient of Pitot tube. But how we are going to do experimentally? If I am going to the lab, then how I have to measure with the help of my Pitot tube? That we'll see for another 2 minutes, so that you will get a more clear idea. Okay. So if I'm going to see, this is my Pitot tube. Here, if I'm going to connect this tube, one end of the limb to one end of the manometer. So I want to connect this one to the manometer. So I'm going to connect this thing. So here you can see up to here it is nothing but my capital H, isn't it? Up to here, let us say the water is there. So this is my small h. So if I'm going to join this one to my one end of the manometer, where I have a heavier density fluid like mercury. So we can see I'm going to have mercury over here. Okay, so let us say I have a heavier liquid. It's a manometric fluid. Now the pressure what I'm measuring will be equal to the total pressure or dynamic pressure or static pressure. That is the question. Now what I did, I put a Pitot tube. When the fluid is brought to rest, the level in the water also rises. So I have total H plus H, and I'm going to connect one end to this one. The other end is rest to the atmosphere. Now what I'll be getting, it means we'll be getting the total pressure because the fluid is brought to rest. So it's a summation of the static pressure and the dynamic pressure. So we are going to get only the, which one? We are going to get the static pressure, the total pressure. But in the formula, which one we want? We want the component corresponding to only the dynamic pressure, or not H plus H. We want only small h. We want only what? Small h. So for that, what we have to do is that, if there's no need to do, already is that along the wall, along this wall, they will make another hole. Along this wall, they will make another hole. So this pressure will give me what? This pressure will give me the static pressure. This pressure will give me the static pressure. Now you connect this end to the other side of the manometer. So here you are getting P total or P stagnation. Here you are getting what? P static. Now I am going to lead one end of this one to the one end of the manometer and the P static to the another end of the manometer. Now this difference will give me, it is P total minus P static, isn't it? Because I'm taking along the wall. Wall means it's nothing but what? Wall static pressure. So it is P total minus P static will be equal to what? P dynamic. So this is nothing but what? H plus H minus H, which is nothing but what? H. So now this difference of height, this H is nothing but my H. I had to substitute in the formula. So I should not directly take that value of H plus H, because that H plus H will give me a value corresponding to the total pressure. But I want only the pressure corresponding to the dynamic. So I want to remove the which one? The static component from the total pressure. For that, what I am doing, along the Pitot tube, I am going to tap a small portion from which I can measure the static pressure. So one end of the limb I am getting P total. This end I am getting what? P total. I am getting P total. This end I am getting what? P static. If I am going to subtract these two things, I will get what? P dynamic. The P dynamic is corresponding to the flow of the fluid. So it is nothing but what? If I am going to substitute this H over here, then we will get the answer. As well as this H will be generated in terms of mercury. But before when you are solving the problem, you have to convert this H in terms of water column. There are certain formulas to convert this H from mercury column to the water column. Then if we substitute, then we can get the actual velocity. Now I hope you have a complete idea about the derivation of the formula for the Pitot tube, what are different types of pressures, namely the static pressure, dynamic pressure, and the total pressure, and how to measure the dynamic pressure or the velocity with the help of a Pitot tube. We have explained. Now you can directly go to the laboratory and you can make use of the experimental setup. I hope you enjoyed it. Thank you.